This video is over topic 44, numbers 5 through 7. So looking at the counting principle with letters and digits. And now we're introducing the can repeat or can't repeat. So can be used more than once, or no letter can appear more than once. Um, so we're using 5 letters, A, B, C, D, and E. Doesn't matter which letters, just 5 letters. And we're making a 4-character sequence. So this is a 4-step essentially. So think of you're picking the first character, second character, third character, fourth character. The first one can be any of the 5 letters. Second one still can be any of the 5 letters. Third one, also any of the 5 letters. Fourth one, any of the 5 letters. This is just picking one out of 5 things and repeating that 4 times. So 5 to the fourth, or 5 times 5 times 5 times 5. And that is going to be 625. So to answer the question, will there be enough badges? Yes, more than enough for the 412 employees. Now, if no letter can appear more than once, then the first character in the code can still be any of the 5 possibilities. Once that first one has been chosen, we cannot reuse that letter. So there's now 4 left that could be the second character. Once we get to the third character, 2 of them have already been filled and used. Those 2 letters can't be used again. So there are 3 left. And then by the time we get to the fourth character, there's only 2 letters left to choose from. So 5 times 4 times 3 times 2 is 120. That's less than 412. So will there be enough? No. Number 6, similar concept, just a little variation. So now we're using digits. So any of the 10 digits from 1 through 9 and 0. And looking for how many 4-digit codes are possible if the digits can be repeated. So then that would be each of the 4 digits in the code could be any of the 10. So choosing 1 out of 10 options and doing that 4 times, there's going to be 10 to the 4th, or 10 times 10 times 10 times 10, which is 10,000 combinations. Essentially, we're looking at how many numbers are there if you're counting from 1 to 10,000, or in other words, if you're counting from 0 to 9,999. So you could have 0, 0, 0, 0, and then 0, 0, 0, 1. So we're just filling with zeros at the beginning, but basically saying we want to get all the possible 4-digit numbers, but then including with that 3-digit numbers, 2-digit, 1-digit, and 0. Um, is equivalent to counting from 1 to 10,000. There's 10,000 of them. Now, how many 4-digit codes are possible if the digits cannot be repeated? Now we'll have that same counting down. The first one could be any of the 10, but then there's only 9, then 8, then 7. 10 times 9 times 8 times 7 is 5,040. Then there's some information about shortcuts if you want to learn and use factorials. Arranging n objects into n positions is n factorial. Again, you can use that calculator button with that symbol to calculate if you need to do like 5 times 4 times 3 times 2 times 1, it'd be 5 factorial. And even if it's not all the way, so for that 10, 10 digits and choosing 4 of them, then it would be essentially filling 4 positions with out of 10 possible items. Then that would be 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times etc. But we only want the first 4, so we're going to divide that by the 6 to get rid of those. So we're taking 10 factorial divided by 6 factorial. The 6 comes from taking 10 minus 4. So a little bit to learn, but if you're comfortable learning that sort of thing, it can give you a bit of a shortcut for the calculations. And then filling, so that's if they cannot repeat. If they can repeat, then it's going to be the number of options to the power of the number of positions that they're filling. And then any combination of those you multiply. So number 7, we have temporary passwords. So key information you need from this is the pattern. So I'm going to write this with L for letter, D for digit. So this is 1 digit, followed by 3 letters, followed by 2 digits. Now, we don't really care about which letters and digits can't be used, but we do need to know how many letters and how many digits are available. And then we need to know they can be repeated. So since they can be repeated, then every digit has 6 possibilities, and every letter has 25 possibilities. And those all get multiplied together. You could shortcut with powers if you want, but 6 times 25 times 25 times 25, 6 times 6, 3,375,000 possible passwords.